Which special segment connects vertex to the midpoint of the opposite side? Median. Got to know that. Median, midpoint tells you those two go together. Did you miss that one, Levi? All right. What is the point of concurrency? Remember, point of concurrency is where all of them come together, right? Point of concurrency of the altitudes called orthocenter. Everybody agree with that? Define a centroid. Tell me what a centroid is. Yeah, you make it harder than it's got to be. Go back up to this one. Centroid goes with what? Median. It's the point of concurrency for the medians. Point of concurrency for the medians. That's all you had to write. Point of concurrency for the medians. State the circumcenter theorem. What does circumcenter theorem say? Circumcenter is always equidistance from the corners. It's always the same distance from the corners. And the triangle inequality theorem, what's it say? We just said it a minute ago. Any two sides got to add up to be more than the third side, or the sum of any two sides of a triangle must be greater than the third side. All right, go ahead and start copying this down. These are the notes telling you what's going to be on this test. No, I'm going to collect them next time, Wednesday. So maybe on here, perpendicular bisector. Thing you want to remember with perpendicular bisector. 90 degrees and congruent segments. As soon as you see perpendicular bisector, you know both those things. Medians, what's a key thing to remember with median? Midpoint. You have a midpoint, you have congruent segments. That goes with median. Anytime you hear that, you should remember that. Altitude, what's the key thing to remember with altitudes? Right angles, 90 degrees. Anytime you see altitudes, you know you have 90-degree angles. Angle bisector. What's the key thing to remember there? Cuts what in half? So congruent angles. So as you hear angle bisector, you got congruent angles. Be able to compare angles and sides, know which side's longer, which side's shorter, because of which angle it's across from. In the triangle inequality theorem we just got done talking about, any two sides must add up to be more than the third side. You got to be able to put those things together, because I guarantee I give you a problem on there, and I tell you that's a median. As soon as you know that's a median, you got to know what's true about these two bottom segments. They're congruent to each other. If I give you that same picture, and this time I tell you that's an altitude, does that mean these two segments are congruent? No, it means that these right here are right angles. You've got to be able to put that stuff together. And if I tell you that, if I draw that same picture and I tell you draw that, and I say that's a perpendicular bisector, then you know those two are congruent and it forms a right angle. You got to be able to put all that stuff with the problem. On the packet that I passed out, I know we only got 5 or 6, 7 minutes. Look through it real quick. I want to do some problems off of it for you. I was going to actually have you do them. This is your homework, but since we don't have a whole lot of time, I'll just do them for you. So looking through there, you'll have to tell me like third page, problem number, whatever, because I don't have them numbered right.
Yeah.
So somebody pick one and everybody else can be looking for one. Which one? 14? If the lengths of two sides of a triangle are 24 inches and 29 inches, then the third side must have a length between what two measures? So they say one side's 24, one side's 29. The third side's got to be between what and what? 5, 53. Same thing we were just doing a second ago, right? How do you find the small side again? Subtract the 2. Large side, add the 2. So that's number 14 on the very front. Should write it in. Anybody find another one? You wrote down the wrong thing. Nobody wants me to do any others for you? Pick one. Let's go. 5 on the front page. PS is perpendicular bisector of QR. QR is the perpendicular bisector of PS. Let's erase all this. So I'm going to have to draw this picture. You got segment PS, segment QR. Terrible drawing. They're the perpendicular bisector of each other. So what can you tell me about all these angles here in the middle? They're all right angles. What can you tell me about these two segments? They're congruent. How about these two segments? Now, does that mean all 4 of them have to be the same? No. If PQ, so from P to Q, that's this right here, that segment is 2x minus 17, and Q to S is 5x minus 23. Find x. So we're looking for what x is. We had a theorem that said any point that falls on this perpendicular bisector is the same distance from one end point as it is from the other. So what do you know about those two? They have to be the same. So what equation can I set up?
2x minus 17 plus 5x.
Ah, come on.
Equals 5x.
All right, I'm going to solve it real quick for you. That'd be 3x. Remember, opposite sides, so you have to subtract them. Bring the 23 over, that'd be 6. Divide by 3, x would equal 2. Make sure you write that down. Another problem. That was first page, number 5. So x equals 2. Was that one of the answers on there? I'm sorry, that was a multiple choice one. So it's D. 5 on the last page. Oh, I see it. I didn't see it at first. They give us this picture, 5 on the very last page. Segment PQ is an angle, or PO, sorry, is an angle bisector. If PO here is an angle bisector, what's the first thing you should think of then? These angles right here have to be congruent. They tell us that this angle is 2x minus 10. This angle is x plus 15. What equation can we set up then?
2x minus 10 equals x plus 15.
Angle bisector. They told you that. You got to know that information right there, right off the bat. It's going to give you x equals what? 25. That's number 5 on the last page. On the second page says two sides of a triangle are 10 and what is that, 23
Oh, yeah.
meters. 10 and 23 meters. The third side must have a length between what two measurements? So we know the third side, we're going to say the third side's between, how are we going to find this low end? How do you find the low end?
You have to subtract.
23 minus 10? So that's 13, that's as low as it can go. How do we find the high side? 23 plus 10, what's that give us? That's your answer. Next question. 2 on the same page. 2 right in the middle of that same page. The perimeter of the, let me draw the picture here real quick. Looks something like this. It's got, looks like it's on a coordinate system, right? Goes up here, here, comes over here, here. This is P, R, Q, S. 7 goes here. 2x minus 3 goes there. 4x minus 10 goes there. And 10 goes here. Says the perimeter of this whole thing is 34. So the perimeter of this four-sided shape should be 34. Then describe the relationship between RS and PQ. So RS and PQ. So if that perimeter is 34, what do you know about this?
4x.
These two together should add up to be how much? All of them together should add up to be how much? 34, right? But how much do we have right here so that we don't have to set up some big long equation? There's 17 right there, right? So these two, how much is left over for these two sides? 34. Remember, you're doing perimeter, not angles.
Oh,
All right, so let's just set it up the long way. Tell me one of the sides.
4x.
4x minus 10 plus what? 2x minus 3 plus 10 plus, and all that should equal, don't say 180.
34.
Thank you. It's perimeter, it's the sides. Collect like terms. How many x's we got? Don't say 2.
6.
6 x's. Regular numbers. Negative 10 and positive 10, what happens there? Cancel out. Negative 3 and a positive 4 is positive 4 equals 34. How do I solve that?
Minus 4.
Minus 4.
And divided by 6.
6x equals 30. Divided by 6, what's x equal? Now let's go back over here. 2 times 5 is 10 minus 3. So that's 7. 4 times 5 is 20 minus 10.
10.
What do you notice up here?
Equals 10.
Those are equal to the same. So the distance from R to P is the same as R to Q. What do you notice down here? Distance from S to P is the same as S to Q. So what do these two do to each other? They are the
Bisect.
perpendicular bisectors. They're the perpendicular bisectors of each other. Remember that theorem that we just got done going over? If this point's the same distance from here as it is from there, this point's the same distance from here as it is to there, then these two are perpendicular to each other and they bisect each other. Give me another one.
4. Second page.
4 on the second page.
Yeah, it's the
At the top?
Yeah.
4 at the top. Triangle looks like this. Is that right? L, N, M, second page.
It's the top 4.
this angle right here is 146 degrees. It says write a compound inequality for the possible measures of angle L, which is right there. So angle L, I'm going to put it like this. The big less than symbols there. Remember, these two angles together, L and M, should add up to equal that, right?
Yeah.
But we had a theorem that said either one of them alone has to be smaller than that exterior angle. So this angle has to be smaller than 146. Well, where can we put 146 at in here then?
On that side.
So the biggest angle L could ever get up to is like 145.999 or something like that, right? It can never get to 146 because it's always got to be smaller than this exterior angle.
Right.
Because these two add together have to equal that 146. Well, I can't put 146 here because if I put 146 there, what would this angle have to be to add up to give us this?
0.
0. Can that angle be 0?
No.
No, that doesn't make sense. Right? Lowest it could go down to
Um,
0.
0.
that's it.
Could go down to 0.
I was actually kind of saw it as a problem. I was like, what the crap is this?
Again, do we know what angle L is for sure?
No.
No, but we know it's got to be between 0 and 146. Give me the next one.
5.
5.
Which
Same
side?
page? Yeah.
Go ahead, go ahead, go ahead.
You guys gonna pick everything off that one page?
Yeah.
Apparently
Page
so.
less to do.
Is that a J? It says list the angles of this triangle in order from least to greatest. So we want to know the smallest angle. Well, the smallest angle is going to be across from what? Shortest side, right? Which side is the shortest? Give me a number. 7.
7, yeah.
Which angle is across from that? H. So angle H has to be the smallest. Which angle is the next smallest?
I.
The one across from what?
8.
8? Is that an I or is it a J? I can't tell
It's
one.
an I.
Is it an I?
Pretty sure.
Alright, so we'll say I.
That's what says in the problem anyway.
Oops, angle. Oh yeah, I should have read it. I didn't read it. So angle I. Which one's the biggest angle then?
G.
The one that's across from the 9.6, so angle G. Smallest, next smallest, biggest. List it, because smallest one has to be across from the shortest side. The biggest one has to be across from the longest side.
I have a serious question for you. If you're doing the exact same kind of problem, but you're doing the angles,
Uh-huh.
would it be the exact same way?
Well, yeah, except then you'd have to name the segments, so you would say like segment IH.
Oh, okay, I got you.
14.
14, where's that at? First page?
Same page.
14's the very last problem.
Oh, I turned my page. Which 14? There's 2 of them.
There's one very bottom, 114 on the page.
There's 2 of them.
Oh, there it is. Okay, I found this.
Just do the shorthand.
Bottom one?
Yeah.
14 at the very bottom of the second page. Looks like this. Give us some picture. It looks like this. That's D, B, A, C, and they tell us D is the circumcenter. Hey, this is a problem I like. If that's the circumcenter, that's the circumcenter. What's it go along with? And these won't be up here next time. What's it go with?
Circumcenter. It's
Perpendicular bisectors.
Yeah.
So that tells us that that's where all the perpendicular bisectors come together. And we had a theorem that said wherever the circumcenter is, it's the same distance from all 3 corners of the triangle. So what do we know about all 3 of these? All 3 of those distances, even though my picture doesn't look like it. They all got to be congruent. Let's see what they ask us here. Segment AD is 6. Find segment BD. Well, how long is segment BD going to be? 6. Is that one of the answers?
Yeah. Well, we got 6. I mean, we only got 5. I mean,
Oh, 5 questions done?
yeah. See, we could do it. Faith.